Our next speaker is a cloud native SaaS specialist and a customer success leader with almost 20 years in the IT world. His career brings together open source work, cloud native platforms, and large scale projects helping organizations build systems that are ready for future. Please welcome Pralhad Sonar.
So, thanks, Raviraj. And once again, I'm Pralhad, almost 20 years in IT. And I find myself lucky enough to be working for few of the most iconic product companies in the world, like Vercel, responsible for Next.js and v0.dev kind of tools, Acquia, PTC, and Enterprise DB. Um, we are going to look at what does it really mean by AI native infrastructure. And because my role as a CSM, customer success manager, it demands for me to be available with statistics, data, insights when I talk with customers. And that is where we are going to start this session as well. We'll start with little context building in the form of statistics. We'll try to get into how best we can define AI native infrastructure when it comes with uh, experimenting and deploying our AI application, not as a part of POC, but also something production ready applications. And what are the core pillars when we talk about the optimized AI native infrastructure, and how future looks in terms of scalability. So let's start with certain statistics. And here is the first one. When we look at the adoption, it goes very fast. It goes with a very considerable momentum, but at the same time, success rate is really low. If we look at the numbers, almost 80% global organizations have at least one AI pilot or a project specific with AI integration in production. And when we look at this 80% number, the next statistics are a little disturbing, because hardly 25% of AI applications or projects they develop get scaled beyond single department. So scalability is a big problem. And after that, hardly 20% of AI project achieve full deployment on production. So then what happens to rest 80% when it comes with deployment? What happens to rest almost 76% when it comes with scalable, getting it scaled up across different departments? That is what we'll be looking at next. So in a way, AI adoption is not at all a challenge, but the scalability. We often look at where to start, why to start, and what all things I should be laced with before I start. Um, More on that is really not a challenge for us when we think about AI implementation, but how best it can be scaled up. That is a real problem. Again, the way we looked at, only 20% project go up to the actual production deployment. What happens to rest 80%? Again, most of this rest 80% could reach to a level of failure. And let's look at what are the reasons, what are the primary reasons behind this failure, why these projects fail. Almost 46% projects link their root cause of failure to limitations in their infrastructure. And when we talk about limitations in their infrastructure, obviously it relates with scalability as well. And infra may not be just specific with your cloud infrastructure, because whenever I talk about scalability, we often think about cloud. It is little beyond cloud as well, deep inside cloud as well, because when we talk about GPU pooling, when we talk about inferences, training your models, that is where these limitations get into picture. Around 32% of applications fail because of poor data pipelines. Now, when we talk about data, if I have a very small product based company and there is a documentation site for my product, obviously it's a single source of information for documentation. And if I want to implement inferences for my documentation site with the help of AI, it becomes very easy, because single unified data pipeline, it works as smoothly as possible. But what if that data is fragmented? among multiple sources, like my official documentation site. It could be my CRM. It could be public ticket system or public communities. Then it becomes very difficult. We will see what really causes the difficulty, because when we have got multiple pipeline resources or sources, data drift is very common. The moment we see data drift, we need to retrain the data, redeploy the models, and if it happens once or after certain duration, it is still okay. But if it happens frequently, it becomes more and more expensive and completely unmanageable. The next part of statistics is 25% fail because architectures are not built for real time inferences or continuous retraining. Can anyone let us know the difference between inferences and training the model? Okay, no problems. So when we talk about training the models, often it's very expensive activity, and it may happen once or after certain duration. Now this duration cannot, ideally it should not be after few days or after a week. Ideal duration is at least after few months, because though it is very expensive activity in terms of complication and also in terms of consuming the infrastructure resources, but because it doesn't happen so frequently, the actual cost specific to that activity is not that high. When it comes with the inferences, so it is just like the way we are interacting with ChatGPT or OpenAI. You know, uh, redraft my email, rephrase this sentence, suggest me some other title for my blog post. These are nothing but inferences, and they do happen on real time basis. And here we are not talking about the frequency like hundreds of times or thousands of times or even tens of thousands of times. No, we are talking about millions and billions of time on daily basis. That is why uh, it is very important that infrastructure should support real time inferences and retraining. Then the last statistic is very surprising. The only 40% applications cite the model accuracy as a reason for their project failure. So, and this is where everything, I won't say everything, but majority of part comes to having a AI native infrastructure to succeed in the initiative wherein we adapt AI features. Again, as a key takeaway, AI doesn't fail at the model level. Nothing, I won't say nothing is wrong with model, but most of the time it is always infrastructure, and reasons being it is not futuristic. We don't look at it from scalability perspective. The cost side of AI infra, 70% of AI operations cost is through inferences, not through training. And this is what we looked at, the frequency. We are not talking about hundreds or thousands of inferences daily, but millions and billions of inferences. And obviously, that's going to add to the cost. And if it is not optimized, it becomes more and more difficult. When we talk about any optimization specific to inferences, we can think about GPU pooling kind of concepts, wherein resources are shared among multiple operations or AI applications or even models. When we look at the utilization of AI optimized environments or infrastructures, so companies adopting AI specific infrastructure, they report at least 40 to 60% reduction on compute when they talk about inferences and rather retraining of the models as well. Any idea about the difference between a vector database and RDBMSs? Yeah. So let's come up with RDBMS. Very simple thing. It's structured, and we often get the data specific to single condition, or let's call it exact condition. Definitely, we modify the things like or into. Let's not look at that as a case for this particular example. When we talk about RDBMSs, we often think about structured data, and the queries are fired to get the exact result. With vector databases, it is more like it works on the principle of similarity. And they also call it as a mathematical similarity. So it's not going to get something very, very exact, but something similar to the query that we have fired. So Here as well, if we adapt to vector databases and um, optimized pipelines, further reduction of 30 to 40% gets into picture when it comes with the cost, and this is very very significant. So now here, obviously, when we optimize something, it has to have positive impact on the cost reduction, and that is what it happens here as well. When we talk about AI native infra adoption trends, at least 75% of global enterprise companies, they have at least one AI application in pipeline, which they intend to get onto the production as well. And this is a very, very big number. If we look at this big number, at least 60% CIOs or chief information security officers, they say AI adoption or the stack optimized for AI application is a primary or number one priority for them for next 25 months. Sorry, 24 months. And when we look at the success rate, the companies who are ready with AI native infrastructure, their success rate increases by 3.5 times more than as compared to the organizations who may not have AI native infrastructure with them. Again, this percentage is very, very significant in terms of saving the cost and in terms of getting the things to production. Because often, whenever we talk about any kind of AI application, we often hear the words like it's POC, it's not production ready, it is just experiment. So here, this percentage will push organization beyond these terms, POC or experimentation, to actual production ready initiatives. Again, this is not something we need to say now. It has been there for last couple of years. It's not a kind of good to have thing. It is more like a baseline for any organization aiming to succeed in ongoing AI race. Let's look at the business impact. So the companies with AI native infrastructure, again, the success rate for them to launch something through successful pipelines or release cycles increases by 2.5 times. Again, this is really, really big change or significant number, almost 150% more success rate than the companies who won't have that. It also records 65% reduction in model latency. And here, this is something which happens on cloud. When we talk about model latency, it could be on cloud. When we talk about inferences, that may also happen on edge. Last but not least, this is very near and dear to me, that up to 50% improvement in the overall customer experience. When we talk about any IT project, whether it is service based or product based, definitely customer experience is the ultimate aim that we try to achieve. And if we look at this percentage of 50% improvement, it's again a very, very significant, and it could be game changing as well. So let's look at AI native infra, and we'll try to define it in very simplistic way. So it is nothing but the infrastructure that is designed specifically scalable, to make the AI application scalable horizontally or vertically, and that is what we look at as AI native infrastructure. And we are talking more from data fluidity, then multiple model support, that we should be able to switch the model as a part of existing architecture. Switching the model by changing the architecture, definitely it's easy, but that is not how we achieve the scalability. Here, it has to happen without changing the core architecture. And obviously, continuous learning. Let's look at the core pillars. Any questions from this slide before we move on to the core pillars? Data continuity. Data is really important, and one of the reason for failure we had seen was fragmented data pipelines, which means data is scattered through multiple sources. So here, data continuity, very first thing, it will ensure real-time pipeline for streamlined data flow. And how, or what all things involved. Very first is unified pipeline. So the source of data is fixed, and if it is not, we need to take efforts towards that. Again, vector databases, we have seen the difference between vector and RDBMSs, and real-time streams. Now, when we talk about unified pipelines or even real-time streams, Where exactly it gets executed, this is another key question, and understanding of it is really good for us. So, when we look at the CCTVs which could be available in retail stores, uh, the face detection or figure detection, human, animal, or some kind of object, that can happen in the camera itself. Okay, that is nothing but an edge device. If I want to pull any kind of analytics for the data for last 5 days, 30 days, that activity would happen on the cloud. Okay, so when we talk about such kind of unification, we need to understand if it is going to happen through edge devices or on cloud. I also have tried to come up with one of the tool for each and every pillar. So when it comes with data continuity, we can make a use of a tool called LangChain, which is very, very helpful. The next is a model ops. We are very much aware about operations, whether it is CI, CD, performance, security. Ops is very, very commonly known department nowadays. Same way, a model ops in a way, CI/CD pipelines needs to be optimized for models, inference scaling, as well as observability. We will look at observability in terms of how best it can be self-filling in next slide. And the simple impact it has, that it will improve the deployment efficiency for your model or resultant AI application. One of the very commonly used tool is Viviat, which you can look at for this pillar. Then the compute elasticity. This is where we talk a little bit about GPU pooling. Um, if we have a dedicated GPU, that may not be utilized fully by a single application or set of models or applications, and this is where pooling gets into picture. So instead of keeping a dedicated GPU idle, it can be consumed by multiple models or applications simultaneously. So we are utilizing GPU capacity at fullest, and obviously auto scaling. Now, edge to cloud deployment. Again, the example of retail CCTV camera, or even if we look at the cars, we often give commands to cars: open the roof or play the music. That everything happens at the edge device. Now, in this case, edge device is our car. If any kind of updates, that has to happen on cloud. So this is how this support has to be there. And again, compute elasticity, the biggest impact it is going to have, that it is going to support the fluctuating demands of your AI application. Again, one of the tool that you can have a look at is Ksurf, kind of industry standard for compute elasticity. The next is a governance model or governance mesh. Uh, Governance, when we look at the security and performance, we have heard this term quite often, but it can also get into picture for your AI native infrastructure as well. So very first thing, if we look at the impact, it's going to help us to build that trust factor and enforce the compliance across multiple AI operations, not as a part of single department, but across multiple departments as well. And what it is going to focus is more like a data lineage. What is the kind of source for that data? How old is that? How structured is that? Is there any kind of dependency of that data on any kind of other data? Anyone can explain the term, the next term, that is explainability, in accordance with data pipelines or AI models. So if I give any inference or context to chat GPT in this example, um, if i say uh, if I say uh, who is the Bollywood actor with maximum Filmfare awards? Okay. Now AI is going to get this data from the data streams that is available for it, and it will give the result. Now, in this case, let's call the example is Amitabh Bachchan. Now, uh, how it relates to this term of explainability in terms of AI's context? Very first thing, how AI has predicted this answer, and second, what all resources it has utilized, and third, most important thing, is this prediction understandable by humans? not only result, but the way it has come up with this prediction in the form of result. That is what it is called as explainability in the context of AI. Access control we all know, so let's not spend any time on that. And one of the very commonly known tool is ML Flow. Whenever you get time, please have a look at it. A very, very interesting tool, and it makes the life simpler. Any questions before we look at the next slides, specific with future ready AI infra? Okay. When we talk about future ready AI infra, here we are not talking just about data pipelines. We are also looking at the scalability. We are also looking at the robust AI performance in accordance with security compliances as well. And most importantly, whenever my application will demand the utilization of different models, there should not be significant change in the AI architecture. So that is a key to it as well. And this is where if you might have observed, whether it is Cursor or the tools like vibe coding tools like V0 or even Rocket.new, we just need to switch the model. Nothing. We don't need to change anything else. The change is at very, very configuration level. We don't do any kind of complicated configurations in that, and that is what we call it as change the model without changing the architecture. When we look at the key elements, when we think about designing for future scale, very first is pipeline. Again, we all are exposed to pipeline when we look at the Git. Here, it is more like a um, uh, training or retraining the models. So, whenever we have problems with unified data pipelines, obviously there will be a data drift. The moment we see data drift, we need to retrain the models, and the moment we get it retrained, we also need to be able to redeploy it. Okay, this is nothing but a simple cycle of pipelines. Again, how frequently it should be done, it really depends upon what kind of data or what kind of application you have. But again, it should not keep on happening on daily basis or even weekly basis, or else it could be more and more expensive in terms of implementation, and also in terms of infra costing. Again, models, the way we looked at multi-model orchestration, we should be able to switch the models on the fly without making uh, um any changes at architectural level. Self-healing, now this is something, the term that is being coined quite often in the context of vibe coding or co-pilot integration with GitHub, or even a Cursor kind of IDs as well. Though not each and every tool is supporting it, but I have been using Vercel's v0.dev quite frequently and extensively, and it has started supporting this. So whether it is v0.dev or even Indian vibe coding tool Rocket.new, please try to subscribe to their beta program, so you get access to such kind of new features. So how it works, whenever it will find any kind of anomaly at infra level, it will tend to fix it on its own. So earlier, how it used to work, whenever any kind of problem or anomaly would get into picture, we would often get email alert or message alert, and then we will get into fixing it out by raising support ticket or on our own. So here, this is where the uh, uh, importance or benefit of self-healing systems would be, that it will detect the anomaly. Beyond that, it will also fix it. And last but not least, observability. And again, observability, we often think just about certain dynamic uh, graphs, very specific with my logs, because we don't like to read the logs in textual format. And it goes little beyond that. It combines observability with governance as well as trust signals. This is where these four elements are very important when we think about future of designing scalable AI infrastructure. A little blueprint, again, a little takeaway as well. So we need to see a shift. We often talk, whenever we talk about AI, we often talk about the tools as well, even as a part of my session, we highlighted certain tools. But again, obviously, that could be a kind of initial direction, but we need to shift the focus from just tool adoption to actual architectural adoption, because that is what it is going to save us. Second thing, build the infra that will learn, scale, as well as govern. Often we see these three things are happening at different levels or stages, or even scopes when it comes with the cloud infrastructure. If that can be combined together, it could be more and more maintainable. And because it could be more maintainable, it will be easy for us to get it scaled up to different levels. Again, momentum. Um, we often look at the most important thing for any AI implementation as AI models. Obviously, it is mandatory, but we don't need to stop there. There has to be some moving momentum towards that direction, which will really help us to secure our AI application and get it scalable. And resilience, so resilience is much more important than how fast we get the things done, or what is the kind of speed we would have to get certain things done. So these are some of the takeaways from my session, um, and I think I'm done with any questions. Yeah. Once again, big thanks for your availability and being so kind with your patience. And also, I would like to say big thanks to QAD 42 team and their team responsible for organizing and managing this event. Thank you.